So example 5 is a word problem that involves a skill you need to have in trigonometry. It's called solving for missing parts in right triangles. And for the sake of this book, we're simply going to be picking out a specific side that we're trying to find or a specific angle. And we can use trigonometry inside right triangles to do this. So if you take a look at what's happening here, a plane takes off and climbs at a 12-degree angle. So that's what this is. Right, here's the runway, the plane is taking off at a 12-degree angle, so it's rising up, right? And climbs at a 12-degree angle. Is that angle sufficient enough to fly over an 11,088-foot mountain that is 12.5 miles from the runway, or does the plane need to increase its angle of ascent? All right, so this mountain, and based on the picture, it looks like we're at the mountain, doesn't it? I don't know. I mean, it's just, again, it's just a picture. But their question is basically, how big is X here with this setup? The mountain's exactly 12.5 miles away from where the plane took off the ground here. The plane is climbing at a 12-degree ascent, right? So it's going up at that. And we're trying to determine if this height is big enough. All right. So the skill that we're going to create here for you is this. I'm going to look at what I have. And again, we are working only with right triangles here, so it being a right triangle is important. One thing that I'm concerned about is this says 11,088 foot, and this says 12.5 miles. So the units don't agree with one another. So the first thing I'd want to do, since the answer I want to get is going to be in feet, I want to see how many feet high the plane's going to be when it gets to that mountain. I want to change my 12.5 miles into feet. Do you guys know anything about feet in miles?
I think it's 5,280.
It's exactly 5,280. Very good. So 1 mile is equal to 5,280 feet. And dimensional analysis is the mathematics we're using here to change dimensions. The idea of dimensional analysis is if you know a fact about two different dimensions, specifically 1 mile is equal to 5,280 feet, I can put 1 mile and 5,280 feet into the same fraction, like so. Since 5,280 feet and 1 mile represent the exact same length, this fraction's value is 1. But if I cancel the unit of mile and the unit of mile, I'm now in the unit of feet. I'm going to have the proper units of feet with the correct number of feet. So if I take 12.5 times 5280, 12.5 times 5280, that tells us 66,000, that looks like. Yeah, 66,000. So the plane's going to fly 66,000 feet that way. Is it going to get high enough to get over this mountain? So that's what I'm going to put in my picture here. So 66,000 feet and 12-degree angle. And then X. And that's all that I get for information in this problem. I don't know how high the plane goes. I don't know the I don't know the hypotenuse of this because I don't know how far the plane's flying in that direction. I just know he's going to cover a horizontal distance of 66,000 feet before he gets to this mountain, right? So, if I'm looking at the acute angle in my picture, this acute angle here, what side is X in relation to the 12-degree angle?
Opposite.
The opposite side. And what side is 66,000 feet?
Adjacent.
That's the adjacent side, because the other side is the hypotenuse, right? So the two sides we know are opposite and adjacent. And if I'm looking at SOHCAHTOA, okay, a lot of times trigonometry is about this simple question. What do I know and what do I want to know? That's it. If you simplify right triangle trigonometry to those two questions, what do I know, what do I want to know? All right? So, what do I know? I know the adjacent. What do I want to know? I want to know the opposite. So if I want to know the opposite and I do know the adjacent, the trig ratio involving those two pieces is tangent. That's how you determine which one you want to use. What do I know? What do I want to know? All right? So once I establish that, I know that tangent of 12 degrees is equal to the fraction opposite x over adjacent 66,000. Now, one thing I don't have is a proportion yet, but if I put this over 1 now, I do. Alright. So again, I'm just creating a basic trigonometric equation here. Trig function of some angle equals some fraction. Okay? And if that thing I set up has exactly one unknown in it, like this, I know 12, I know 66,000, I do not know x, it can be solved. And the information I need to know is what tangent of 12 degrees equals. That's what a calculator knows. So I go to my calculator, I make sure my calculator is set to degrees. All these gray ones are set in degrees. And on these gray ones you have to hit the trig button. It's like right above some other button. You have to hit second. Second pi. If you hit second pi, it'll bring up a trig menu, and it'll have a little menu of sine, cosine, tangent, different things you can do. So what I need to know is what the tangent of 12 degrees is. So I'm going to punch in tan 12 equals, and it spits out some number. Now, I don't want to hit this mountain. Do you guys want to hit this mountain? Okay, so I'm going to go a lot of decimal places here. I want to be sure that I'm getting over this mountain. So I'm going to go like 6 decimal places, 0.212, 557. All right. Again, I just rounded to the 6 decimal place, 1, 2, 3, 4, 5, 6, yeah. And then notice my proportion that I have here is simply just 1 times x equals that product there, right? So to get the answer for x, I'm just going to do 0.212557 times 66,000 equals, that's going to be 14,028.76 feet. The mountain's 11,088 feet. By the time this pilot at this 12-degree ascent angle reaches the mountain, he's going to be 14,028 feet high, which is almost 3,000 feet higher than the mountain. So he is safely on his way to going. So apparently that's a bad picture because maybe the mountain was more like there. Right. He's not going to hit it. So anyway, whether it's a word problem or anything else, this is what you want to be able to draw anytime you deal with a right triangle trigonometry problem. A right triangle with everything you know in it and what you're trying to find in it, and then it's just what we've been doing. Identify an acute angle, identify opposite, adjacent, hypotenuse, whichever ones are involved in the problem. And again, if you're trying to find a missing piece, what do I know, what do I want to know? And that establishes which trig function can help you find it.